So what we're going to be doing today is learning how to do laminate finite element analysis using ANSYS Workbench. For this tutorial, we're going to be using ANSYS ACP, which stands for ANSYS Composite Prep Post, and that's just an add-on for ANSYS Workbench. So I'm going to load up Workbench 18.1. And then we're going to start by dragging over the ACP pre module into the workspace. So first of all, we need to set up our engineering data. This includes all the composite materials that we're going to be using. So double click on that, and then up here in the upper left, click on engineering data sources, and we're going to scroll down to composite materials. Double click on that, and then you'll see all the options for materials listed down below. For our analysis, we're going to be using epoxy carbon woven prepreg, so add that, and then honeycomb as well. So go back to the project, and now we can start to import our geometry. A few things to keep in mind before doing this is that Workbench works very well with parasolid and .stl files, so we're going to use a parasolid for this example. In addition, ACP works for either solid or shell elements. For thinner laminate structures, shell elements work better, so we're going to focus on that, but solids work as well. So we're going to right click on the geometry section, then import geometry, and I'm going to import my parasolid file. This is going to be just a very simple box with some rounded edges and drafts on the side. So now that we've loaded the geometry, we can load the model, and this will load mechanical so we can mesh and define thicknesses and such. So now that mechanical is loaded, you can see that we have our little box or tub here. Now what we need to do first is ANSYS wants a thickness for this part. The thickness does not end up really mattering at all because ACP will reset that thickness and apply the correct thickness later on, but we'll just set it to 3 millimeters, how about? And then we need to mesh this. There are many different meshing options, such as like face sizing or refinement, but we'll just do a really simple mesh by going under quality and then setting the target quality right here to 0.95. Then to actually mesh this part, we're going to click Generate Mesh under the Mesh tab in the toolbar. So you can see it's a pretty basic mesh, nothing too fantastic, but it'll work for what we need. There are definitely more advanced meshing options that you'd want to go into for a more complicated part. Next, we want to create some name selections for this part. And as you can see in this geometry, there are many different faces that you can hover over, but we want to define certain selections of these faces that will be used later in ACP. So I'm just going to select the bottom here, and then right click and create name selection. We'll just call it bottom. Then I'm going to deselect this bottom part, and then create a final name selection for the edges. So then we can click Update Project, now that we're back in the workspace. And then we can double click on the Setup option here. This will load ACP Pre, and this will be where we'll be applying all the different materials and material thicknesses and layup structures and everything to the part. So first in ACP, you can see that this is the general UI of it. We have our visualization screen here, and then all of our different laminate options on the left. So first we're going to go into material data, open that up, and then you can see under materials we have our carbon fiber and honeycomb. So we want to create fabrics out of these different materials, and you can right click on fabrics, then create fabric. We'll just name this prepreg, and the material is going to be the prepreg. This thickness is going to be in meters, so the nominal thickness of a ply of prepreg is going to be about 10 thousandths. So that's going to be 0.000286 meters. And then I'm going to create another fabric for our honeycomb. The thickness on that, we're just going to use a 1/4 inch thickness, but this could be any desired thickness. So next, we're going to create a stack up. This basically creates a series of plies, so then we don't have to define it later in the ACP process. So with this, we can just call it stack up, and then we can add, I'm going to add 5 different layers of prepreg here. I'm going to change the angles on them. This just determines the material orientation direction relative to an axis that we'll set up later. So I'm going to set the first one to 0 degrees, second one to 45 degrees, third to 0 degrees, and second to 45. This is not necessarily an ideal layup structure, but it'll give you an idea for what to start a part like. As you can see, the layup sequence is top down, which means that the bottom ply will be this first ply, and the final ply to be laid will be this last ply. So as you can see under element sets, we have all the elements that were defined in the name selection. So what we need to do next is create rosettes, which are basically coordinate directions that define how the materials are oriented. So we're going to right click on rosettes, create rosette, and I'll just leave that as rosette 1. And what you can do next is click on the origin box and click anywhere on any of these faces. We want to define this rosette for the bottom ply, so we're going to click on this bottom face. And what these do is they define the material directions, where direction 1 is 0 degrees and direction 2 is 90 degrees. For this example, we want the 0 degree direction to be in this direction, as you can see from my mouse. So we're going to orient the 0 degree direction in the negative z coordinate direction. Therefore, we have 0 degree, 90 degree. Next, we're going to create a second rosette. This is going to be for the edges. So I'm going to click on the origin, select one of the edges, and then what we want to do is change that to the same 0 direction. And then we're actually going to change the 90 degree direction to the upwards direction, because this ply is going to be facing a different way. Now that we have those two rosettes, we can go under oriented selection sets, right click on that, create oriented selection set, and we're going to name this one bottom. And what an oriented selection set does is it selects the element sets that were defined up here, the rosettes that are defined down here, and then a material stack up orientation. So we're going to call it bottom, and the element set that we're going to create or select is going to be the bottom. Now the orientation is the direction that the plies are laid on each other. So for this instance, we're going to click on the point box, select a point on the face. As you can see, that little purple arrow right here is pointed downward. We actually want the materials to be stacked up in this direction. So that would be in the positive X direction. So we're going to flip that, clicking that flip button, and then we're going to click inside of the square brackets again to select the proper rosette. That's going to be rosette 1. As you can see, that's the correct rosette, and we're all good for the bottom. Next, we're going to create a second oriented selection set. We're going to call this one all, just because it's going to be selecting all of the elements. Again, click inside element sets, select the all element set. The orientation, we're going to again click on the face, flip it, and the rosette is going to be the same one that we defined before. Finally, we're going to create a last oriented selection set for the edges. I'm just going to call this edges. Select the edges element set. Now the point that we want, we're going to click on one of these edges around the sides of the box. So let's just define it near where we did the rosette. Click right there. As you can see, that is oriented in the opposite direction that we want. We want it facing inward. So we're just going to flip that. And then we're going to click on the rosette that we created. So that's going to be rosette 2. Okay. Now every once in a while, you're going to want to save this project and then update it. What that does is it updates all these oriented selection sets. So then we can go on to creating a modeling group. This essentially defines all of the plies and the core and how the layup is structured. So we're just going to leave it at the default name of modeling group 1, and right click on modeling group 1, create ply. So now what we're going to do is select the oriented selection sets. So click inside the square brackets, and for this example we're going to want to select the oriented selection set called all. Next, for the ply material, as you can see we have the options of honeycomb, pre-preg, and then the stack up. We're going to want to use that stack up that we created before, so we don't have to go ahead and define 5 new plies. Finally, we're going to leave the ply angle at 0 because we had already defined those angles in the stack up. So I'm going to click OK, and if we update that, if you click on this little plus next to modeling ply 1, and then another plus, you can see that all 5 of those plies that we had defined in the stack up right here are available right there. So next we're going to create next ply. That'll just be created as modeling ply 2, and I'm going to select the oriented selection set of edges, and then use the same ply material as the stack up. Leave the ply angle at 0 again, and this is going to define the same stack up just on the edges then. Next, what we want to do is create the honeycomb core. So I'm just going to call this core. Select the oriented selection set of the bottom, and then assign the ply material to honeycomb. So then what that means is we don't need to define the ply angle because we're just going to leave it at 0. Next, we're going to create basically a symmetric set of plies similar to modeling ply 1 and modeling ply 2. So we're just going to go about this the exact same way. Oriented selection set, edges, ply material, stack up, angle 0. And then create your final ply. This is going to be oriented selection set all. Oriented selection set all, ply material, stack up again, and then ply angle 0. Let's update that then. And as you can see, it defines the thicknesses correctly. These are all in meters, but you can see that the honeycomb is going to be the thickest because we have a 1/4 inch thick honeycomb right there. Save the project, and then we're going to go back into Workbench. So next, what we're going to want to do is put all of this setup for ACP pre into static structural. So go over to the left side, drag static structural, and create a new module. Then what we're going to want to do is click on this setup area, and then drag it over to the model. Since we're using shell elements, we're going to transfer only the shell composite data instead of solid. So now what we can do is update the project, and then we're going to go into setup under static structural. So double click on that, and it'll open another version of mechanical that'll allow us to define loads and displacements for different points on this part. So now that we're in static structural, if you go to this left toolbar and expand the imported plies section, you can see that ACP has imported all those different plies that we had created before. So you can see that there's the core ply and each of these stack up plies that we had defined. Next, we're going to go into static structural, right click on that, and we're going to insert fixed support. For this support, we're just going to define it along the top edges of this box. So we're going to want to go into the upper left here and click on the edge selection tool, and then just select the edges while holding control, and then click on apply. So you can see that it selected all 8 of those edges, and those edges are going to be fixed in space. So they're not going to be able to move when we put a pressure on this top face and then a force on this side face. So next we're going to go into static structural again, insert pressure, and then we're going to want to select a face this time. So we're going to select this bottom face, apply, and we do want it to be defined normal. This arrow looks like it's going to be in the correct direction. We're going to want to apply it that way. And then the magnitude of this, let's do like how about 1/10 of an atmosphere. So 0.01013. Next, we're going to insert a force. We're going to want to select one of these faces. I'm just going to select this side face. I'm going to change the define by to components, so then we can define it in the positive z direction. So we're going to call this 200 newtons in the z direction. As you can see, it's going to be a force that's going to be applied all across this face. Next, for the solution, we're going to want to right click on that and insert the composite failure tool. This is bundled with ACP and allows us to add different failure criteria. So we're going to right click on composite failure tool, insert, and safety factor. So we have both the inverse reserve factor and safety factor. To actually figure out what failure criteria we want for that, click on composite failure tool, and for this we're going to use maximum strain, maximum stress, the puck failure criteria, and then we're also going to want to scroll down to face sheet wrinkling, as well as core failure. It's good to use multiple failure criteria, so then we can get an accurate gauge for where and under what modes this material might fail. Maximum strain and maximum stress are pretty straightforward. It's the maximum in-plane strain and in-plane stress of the materials. What's really nice about the puck failure criteria is that it analyzes whether the material is failing under the matrix or the resin, or whether it's the actual fibrous material. Finally, if we have a sandwich laminate, which we do because we have a core that's right in the middle here, we're going to want to also put on face sheet wrinkling, which basically means buckling of the face sheets, and then core failure, which would be under compression typically. Next, we're going to also add deformation to the solution, as well as von Mises stress. For the stress, we can define it by the ply, but I'm just going to do it for the overall layer. So now that we have all that, we can go up here and click on Solve. So now, as we can see, here are the results of our analysis. If we go into total deformation, you can see that the most deformation was seen where we applied that 1/10 of an atmosphere on top there, and it appears as though the force along the side did not do too much. 200 newtons is not a whole lot. We can also go into the safety factor, and as you can see, since we had a pretty thick laminate, the safety factor is around 5, which is would be fabulous for a part like this. So there is, if we go back into Workbench, there is an ACP post option. That's basically just a post processor for the results that we've seen in mechanical right here. It can be more accurate for some more complex structures, but at this point we're not going to go into that.